Hello again. In this video, I'm going to go over this homework problem from section 2.2. And so in this problem, they give us this function g of t. And for this function g of t, we're supposed to find the output values for these three input values, and then also for these three input values. So in other words, we're going to evaluate the function at these 6 different values. And then once we create that table, we're going to try to determine the limit of this function as t approaches 16. Okay, so I'm going to show you how you can create the table using the calculator. Okay, so the first thing you've got to do is go to this y equals button, and then we're going to enter the function into y1. Okay, so I'm first going to write the top piece here by opening up parentheses, and then they don't have a t on the calculator, they have an x, so go to your x here, and then minus 16, close parentheses, and that's the top part of this function. And then we have to divide that by, and again, I'm going to put parentheses around the bottom part. And now you have to go to square root of t, so go to your square root button, which is a second button feature. So we'll go to second, and then the square root is right there. And then square root of x, close parentheses. And so you can see this is the square root of whatever's in the parentheses, right? So the square root of x, and in fact, I've made a mistake. Let me go back. I want to delete that. It should be the square root of, no, that's correct, square root of x. So it's taking the square root of whatever's in the parentheses, right? In this case, x, and then minus 2, or minus 4. And then I'm going to close the parentheses for the bottom part. Okay, I opened up the parentheses here for the bottom piece, and now I'm closing it off here. Okay, so just enter that function into the y1 piece here. And then after you've done that, then you want to go to your window button and make sure you adjust your window so that it will contain the range here for the x values will contain the domain values that you're interested in, and the y range will contain the outputs for that particular range that you're working with. So for us, we're inputting values around 16, a little less than 16. So if I go from 0 to, say, 20, then that range, 0 to 20, contains all the input values that I am going to be putting into this function. Okay, and then the y range is hard to know, but here's the answers that are going to come out. So it looks like they're near 8. So I'm just going to go from 0 to 10, which will contain all the output values here. Okay, so you may have to adjust your window, okay, for this to work. Okay, and then after you do that, go to calculate, which is a second button feature. So second, and then calculate is right here. And then you want to enter in value. You get this little menu here, and you want to select value, so press enter. And then it will prompt you for the x value that you want to put in, and we're going to put in 15.9. And then press enter, and this is the output, 7.9875, if you round that off to 4 decimal places. Okay, so that's the, if t is 15.9, then this is g of 15.9. Okay, and then we could just do this for the other values as well. You know, I may do a few more here just to show you. Go to back to calculate value, and now do it for 15.99. And of course, the answer you get is 7.9987 rounded to 4 decimal places. Okay, and so you can do this for every one of those values, okay, until you get to the last one here. So that's how you can do that real nicely on the calculator. And then just to finish this off, part B says make a conjecture about the limit of this function as t approaches 16. And so you can see from the table that as t is approaching 16 from the negative side of 16, you can see that the output values are approaching 8. Whereas when t is approaching 16 from the positive side, it's also approaching 8, but from above 8. This one's approaching it from below 8. So this is a case where the left side limit and the right side limit are approaching the same number, right? They're both approaching 8. And so this two-sided limit would also approach 8. And so that's the answer for part B, right? This limit would approach 8. Okay, so I hope you found this video helpful, and I'll continue to work on some problems in Chapter 2, and hopefully you'll have a chance to look at some of those as well. Okay, bye-bye.